how applications work. I think we kind of covered this once before in this class, but I want to do it in detail because really the use of a database is to make some piece of application work. So if you don't understand how applications work, this isn't going to work well. So you start out with some sort of a client. And by client, we're talking about a browser. We're talking about things like Electron, which is a web browser, but it is running on your desktop. We are talking about some sort of custom client. Okay. Custom clients are things like WhatsApp and pieces of software that have been written that are custom clients that are native. WhatsApp is an example. There are a lot of custom clients. E-Trade's application. Okay, although custom clients are becoming less common today in favor of things like React Native and what's another example of something? But there are a number of these things that are out here that are web technologies built to build custom applications on mobile so that they're portable between different things. But a client. In fact, you can also have clients that we will use for testing, quite likely, like wget and curl. Those are command line clients that just pull back a file. But they're perfectly good clients. But you have some sort of a client. And most often what's going to happen when you have a client is it starts out with an URL, and that URL has to be turned into something that it can actually use. When I get an URL, the first thing that happens with that URL is it goes out to a DNS server. Now, some places like the University of Wyoming run a local DNS server, so you don't go very far. Most people in their homes do not run a DNS server. I do, because it cuts about half the time to fetch any page. At that DNS server, it turns the URL into an IP address. IP version 4, IP version 6. Now, this is a database lookup, and if you use the original bind DNS client, it uses a database called Berkeley, which is a hash store database. But most big organizations today, like GoDaddy, use a database based on Postgres to do the lookups for these DNS names. And there are a number of these things, but almost all of them are based on Postgres because Postgres has native data types for storing IP addresses and manipulating IP addresses. Now, when it gets done, it sends back a result that is this IP address. That usually is the start. Okay, now quite often right here before it goes through, there's a proxy. This is a front-end proxy. Certainly the University of Wyoming runs one. Quite often that proxy is a caching thing, like Squid. Okay, so that if you make the same request twice, instead of it sending the same request through, it will know to send it back from here and you just get back the same information. So again, Squid is used in a lot of businesses, a lot of large organizations, very rarely in people's homes, although I run it in my household, and it makes things much faster. To give you an idea, for one of the things, I downloaded a copy of the ISO for installing Ubuntu and accidentally downloaded it twice. The first time took 2.5 minutes, the second time took 4 seconds. So guess what? It had to be coming out of the Squid cache locally. Because you don't get that kind of speed of 4 seconds for a 3.2 meg or 2.3 gigabyte, file, unless it's being hit locally. So, yeah, I didn't really need it twice, but that gives you an idea of the kind of performance change. Now, after it gets done with this, it then goes out to that server and it wants to get a file. This is the normal thing. It wants to get something like index.html, and it wants to get a file. When it goes and gets that file, It's going to pull back the file and it's going to parse it. And that file comes from some sort of a server. A lot of places run Apache or Nginx, Nginx. I tend to run Nginx. I prefer it much over Apache. But that's a preference. Lots of good things about Apache too. But generally speaking, it pulls it from here. Now what happens is we have a file system on some server, and Nginx usually is just pulling from that file system. But it could be doing something else. It could be acting as a forward proxy, okay, and proxying from there to some other piece of software to run this and get this. And most application servers out there today work in this fashion, where they've got some sort of a front end and static resources are pulled directly by the front end, but other resources are going as a forward proxy to some sort of application server. You will not see a lot of cases where index.html is an application, but there's nothing stopping it from being served by an application server. And sometimes, yes, things like WordPress are serving it. And there are big WordPress sites, like New York Times, that are running customized versions of WordPress, and index.html is being served by an application. So it's not this way, but if you look on the New York Times, you'll figure out that yes, instead of them even serving the New York Times logo at the top, they have said that they will go to a third-party provider to serve that static resource. Now, when it gets back with this file, it parses it. And it finds things in it like an image tag. Okay, like the logo. Okay. And that image tag as a logo means it's going to go out and it's going to find this. Now, this could be a full URL. Like in the case of the New York Times, it's a full URL because it comes from a different location. And on the average page out there on the web today, the average application, there are 96 DNS lookups. Okay? So it's going to do this DNS thing 96 times to be able to figure it out. Most clients, like Chrome, cache those DNS results. So if you get one, once you've gotten it, the browser itself, not even something like Squid, is caching it locally in the browser on your system. This means that you can't go and change it locally until you restart the browser usually. Chrome keeps this cache alive until the browser gets terminated and rerun. So there's a bunch of static resources. Images, cascading style sheets, JavaScript, structured vector graphics, all these different pieces that make up whatever this page is that it's rendering. Now, this rendering process is really good at getting stuff painted down to the fold on your page. Usually that's a pretty large page. But down to the fold quickly, but most pages, like it takes on average over a minute to render Amazon's homepage by the time it actually gets done rendering and making all these requests. And you'll find that an awful lot of these are the same way. They take a long time to pull all the pieces and get everything put up there and paint everything. Even though what you see when you click on the browser is it goes chink and it loads something fairly quickly to start off with. Now, that means also that on an average load, you're looking at something like 2.3 megabytes of data. So it's sitting here doing all these things. Now, when it gets back these pieces that are JavaScript, it probably is going to run them because it's a programming language and it's going to start doing stuff. Now, that's also part of the reason how it works, is it goes out and it does stuff. Now, I mentioned Postgres over here at DNS, but one of the things that happens with an application server, certainly, is it's going to go out to a database and it's going to start pulling in stuff. And the most common databases out there is MySQL or MariaDB, Oracle, SQL Server from Microsoft, and Postgres. And if you were to look at a graph of utilization of these in the past 5 years, what you'll see is that there's Oracle, there's MySQL or MariaDB, and there's SQL Server, and they're all trending down a little bit. And here is Postgres doing this. Okay? There's one other database that's doing that out there, and that is MongoDB. But basically, over the past 5 years, it's been growing. A big part of the reason for this is two of these are owned by Oracle Corporation, MySQL and Oracle's database, Oracle. And Oracle Corporation has not done much development on these things in a long time. And nor does it look like it's going to. For instance, in MySQL, there's the MariaDB, which is the open source. There is the Oracle side of it, which they sold their business to Oracle, but it was still open source and they could do things with it. And inside Oracle, the amount of new tests that have been built and released to the public in MySQL has basically gone to zero. And if there are no new tests, there is no new code. The number of new features that have been implemented has basically gone to zero. So these things are basically what I would call dead. There's a defect that I issued 22 years ago against the Oracle database that has had every single release since then. It has been marked as this is something that should be addressed. It still hasn't been addressed, and it's a common use case. So these things are not progressing. Whereas Postgres has gone from version 9 to version 12 with major additions in every version and improvements in speed. Postgres has also seen implementations of stuff like Google has a version that runs on top of its F1 file system, which is a highly distributed file system. Amazon Web Services has an internal version that it uses that also is based on a distributed system, based on Big File. Or is it Big Table? I forget whether it's Oracle or Amazon Web Services that has Big Table and Big File. But these things are out here, and there is CockroachDB. That's Google's F1 made in a open source fashion that doesn't require the use of atomic clocks. There are other things. There is a scalability group that has reached over 1 million transactions a second, and has a reference implementation that you can implement if you've got deep enough pockets. So Postgres has lots of features. The biggest one, as far as I'm concerned, is PostGIS, which is the best GIS application out there for databases. But what happens? We're painting something over here on the client. It finally paints. We get a response. We've been through all these pieces. Out here in the middle, there's, the frame cloud that it keeps going through. That's where it sends stuff in, and somehow magically the routers in between take it from where you are to where it needs to be. There's quite often these forward proxies. There may be load balancers in between. But basically, when you get down to it, all the things in between tend to be somewhat invisible. I mean, they take time to run. But basically what you're doing is you're saying, at some point, I'm making a request that's going out to an application server. And that application server is doing some processing. It's turning something into some text that it's turning around and then sending it back. So that's what's happening inside an application. Now, sometimes you have a database over here on the client side. Okay. This isn't very common, but there are certain applications that do that. And that generally is not a Postgres database for lots of different reasons. This is usually SQLite because it's in all the browsers and accessible. But it is an SQL database, and it does use SQL just like anything else. And out of the application server, quite often you have log files, and the log files, quite often, are then shipped off to yet another database, quite often a time series database, and there is a Postgres time series database that is very good as well. But there are other time series databases. And that's so that you can do monitoring and figure problems out that are coming out of the logs out of your application. And there's also logs that get consolidated from there. And you may have a microservice architecture, so you may have many different applications out here running that this thing is sending stuff back and forth to. Netflix is an example of that has many applications, and all of them are consolidated into a single time series database for logging. So there are various places in here where you see the data stored in a database. And there are custom databases for some of this stuff. Quite often, this is a really common case here, is that somewhere out here in the land of the application, right in here or here, you have a NoSQL database. Okay, like Redis to do caching, or queuing, or some special purpose that they've got to keep up with information on. Maintaining of web page state information for applications. A lot of times Redis is used for that, especially in the context of applications that are built with .NET. Because what it would like to do is send the state information out to the client and then get the state information back each time. But that tends to reveal secrets. It tends to be expensive. It tends to use a lot of bandwidth out here. So instead, they stick it in a Redis database over here on the server side. And it looks to the application like this is happening, but it's all being processed in between in a local database. So this is kind of the picture of how most applications are built.